Okay, the first thing I want you to do in your notebooks is title your notes, writing equations from tables. That's what we're talking about today. A couple weeks before Christmas break, we learned about two types of relationships with the table. You look over there on the polka dot wall, I have an anchor chart still posted called additive and multiplicative relationships. And on the left, you see additive relationships where you are determining the value of all of the y numbers based on the equation for x. So x plus a equals y. So if you look at the very first row, y, which is 4, would equal 2 plus a. And in that case, we determined that a represented 2. Okay? Multiplicative meant you were multiplying a number times your x value. Today, we're basically doing the same thing. We're going to look at a table, and we're going to determine what the equation, the y equals equation would be for that type of table and for the numbers in that table. So the first thing I want you to write is the word additive. Now, all of your equations are going to start with y equals. So an example of an additive equation would be something like y equals x plus 3. Meaning when we look at our chart, all of the values in the x column, we're just adding 3 to get our y values. Now, as a quick reminder, when we learned PEMDAS this year, we learned to write it like this. The A and the S were even, the M and the D were even. Well, same thing here. An additive relationship can be adding or it can be subtracting. So an additive relationship would still be true if we said y equals x minus 2. Any adding or subtracting we're going to call an additive relationship. So let's look at an example in a table. We're going to draw a table on our notes. And I want your table to have at least 5, or not at least, I want it to have about 5 columns, so 10 squares total. This part of our table is the X row. And this is the Y row. For your X values, I want you to write 1, 2, 3, 4. For your Y values, I want you to write 6, 7, 8, 9. As we determine the relationships for our tables, we're never going to go across. We're never going to say, oh, it's plus 1, plus 1, plus 1, plus 1, plus. We're not doing it across. You are looking vertically. You're looking at the relationship between x and y for each set of numbers. We're looking at these relationships. So we're going to start and we're going to look at the first one. How do I get from 1 to 6? If I said this is an additive relationship, how do I get from 1 to 6, Axel? Add 5. So we're going to write plus 5. Just in that little blank or somewhere in your chart, write plus 5. Now, a rule means it has to be the same for everybody. So that plus 5 rule has to work on all of these sets of numbers. What is 2 plus 5? 7. What is 3 plus 5? What is 4 plus 5? 9. So it works on all of our sets of numbers. So that means that our rule, what did I say your rule always starts with? Y equals, and our rule is going to be right here. I want you to circle it. X plus 5. That's our rule, or our equation. Because the rule doesn't equal 5. Y equals x plus 5. We're trying to get the values because sometimes these will be blank and you have to figure out what goes there. Now, one other thing I want to remind you of, and you don't need to write this down, but right here we have an equal sign. That makes this an equation. If we had a sign that looks like this, like this, like this, or like this, that makes it an inequality because it's not equal to. This is an equation because it's equal. Okay? So that's an example of an additive relationship. I want us to now do an example of a multiplicative. So write multiplicative on your paper. Multiplicative can obviously be multiplying. When we multiply in an equation, we write it as a squishy. So we could have y equals 5x. Remember that that is the same thing as y equals x times 5. But they like us to write it as a squishy, like 5x. The same is true for division. So if we know that additive can be adding or subtracting, then a multiplicative can relationship. I think I added an extra syllable there. A multiplicative relationship can be multiplying or dividing. So we could write a division equation one of two ways. You could say x divided by 4, or you could say y equals 1/4 x, like a squishy. If you don't know this, these are the same thing. X divided by 4 is the same thing as multiplying x times 1/4. Now let's draw a table so we can do an example. Draw your table the exact same way. Your x values for this one are 2, 4, 5, and 7. I skipped it intentionally because I want you to see we're not looking at this relationship. Your y values are 4, 8, 10, and 14. I want you to circle this so that you remember we are looking at the relationship between these numbers. So we have two options here. If I look at my x value and I'm trying to get to my y value, I could either be multiplying times 2 or adding 2, right? Because 2 times 2 is 4, 2 plus 2 is 4, right? So we need to see which one stays true for all of them. Well, what is 4 times 2? 8. That would work. What is 4 plus 2? That would not work. So I'm going to cross that one out. So far, times 2 works for all of them. What is 5 times 2? What is 7 times 2? So does that work? So we need to write it down. Always starts with what? Right, equals 2. Now, circle your rule. It's x times 2. How do I write that?
Squish it.
As a squishy. Y equals 2x. Which, like we said, that's the same thing as writing y equals x times 2, but we want to write it as a squishy. Because in 6th grade, that's how they write it.